Hello everyone. How are you guys doing today? How are you? Any question before you start? Any comments? Hmm? I know the room looks empty, but many people didn't drop. So why are they sleeping probably? Or they're already having their weekend. For us, it will be tomorrow, but for them, probably it's today. So in our last class, we started 12.3 and we talked about transformation, exponential graph. So the format of exponential graph, evaluating exponential graph, their transformation, horizontal asymptote, all these things. Today we are going to do solving exponential equation. But before that, one last question about the graph on the left page. Which of the equation could be the graph below? We have y equals e to the power x minus 1, y equals e to the x, and then minus 1, and C and D have no idea. So you can omit C and D because we didn't learn about those things. So the answer is between A and B. Which one do you think is the correct answer, A or B? Patamoto. B? Why do you think that? Good job. Great. So if you compare the original one with the given one, I mean the given one with the original one, the original one always goes to the y value 1. So this is e to the x. And we can see clearly our y-intercept went 1 unit down. So if you have a minus 1 means going down, plus 1 means going up after your exponential function. So you see the exponential function and then minus 1, so it's up down shifting. So correct answer is B. In the final exam, they will give you one of the graph, either from the exponential graph or their inverse, which is logarithmic graph. So this thing you see here, it's called LN, small l, small n. It's mean natural log, which we are going to learn today. I mean, not in details, but we're going to use them. So exponential function, sorry, not function, equation. We are going to solve exponential equation. Before we solve, let me tell you, there will be 5 types of exponential equation. Their first steps are different, but once you take the first step, then for 3 types, the last step is all same. After first step, everything is same. 5 different types. So to solve equation, exponential equation, we're going to use the concept is that as long as you have the same base on both sides of the equal sign, you're allowed to cancel your bases, and then you set the power equals to one another, and then solve from there. That's the main purpose or main way of solving exponential equation. And then there will be another scenario where we cannot have the same base. So if you cannot have the same base, Then we need the help of the opposite of exponential, or the inverse of the exponential, which is called logarithmic function. So if you don't have same base and you cannot do anything about it, then we use log to solve exponential equation. And if anyhow you can have the same basis on both sides of the equal sign, then our goal is to cancel them and then work with the powers. Now for each type, I wrote down the type and then how to solve them. So type 1, same base on both sides of the equal sign. For example, this one, 5 to the 2x equals 5 to the 3x plus 2. We have the same base, 5 and 5. So if you have same base, the steps are cancel both bases, set the power equal to one another, and then solve for a variable. So we have same base, cancel them. So we get 2x equals 3x plus 2. So cancel both base, set the power equals to one another. And now, using algebra, solve for x. So to solve for x, what do we do? Subtract 3x, subtract 3x. So we get negative x equals 2. Divide by negative 1. We get x equals negative 2. No, we don't have to check exponential. We have to check logarithmic equation. They're enemy. Exponential and logarithm, they are enemy of one another. They hate each other. Now comes the second scenario, second type. And this type has two different bases on both sides of the equal sign, but we can rewrite the bigger base in terms of the smaller base. So a smaller base is 2, bigger base is 16. Can we rewrite 16 as 2 to the some power? 2 to the what power? 4. So we don't have same base, but we can rewrite them so that we can have same base. So in this case, we are going to rewrite the bigger power in terms of smaller power so that we have the same base, cancel them, work with the powers, just like the first type. So the first step is different. You rewrite the bigger base using the smaller base. So these two, we keep it. It has nothing to do. And we rewrite 16 as 2 to the 4. And we keep our power 3x minus 1. So we have, what power 2 has? 1. 2 to the power equals 2 to the, what we do when we have 2 powers? Distribute, so we multiply them. We get 12x minus 4. Now, do we have the same base on both sides of the equal sign? So we're going to do the exact same thing what we did in the first type. Cancel them, work with the powers. So 1 equals 12x minus 4. And now it's simple algebraic equation. No more exponential equation. If you want to get the epsilon, what do we do? Add 4. So we get 5 equals 12x. The last step is divide by 12. So that tells us our x is 5 over 12. Come on. I don't know what's wrong with this oil. Maybe I should just put it this way. It has to. Okay. Any questions so far?
Would it be wrong to simplify till x minus 4? Like 2x minus 4?
4 doesn't have any x. So they are not like term. That's why we added 4, because they are not like. Try this one by yourself. We have 3 to the power 2x minus 3 and equals to 27 to the power x minus 2. In the final exam, you're going to have 2 exponential equations. 2 of these from 5 types. Ready? Volunteer. Who would like to help me with this? Mariana.
We're gonna keep most of the left side, and then like 27 is 3 to the power of 3, right? And then x minus 2. Now, we're gonna multiply the 3, again, keep the left side, on the right side it says 3 to the 3x minus 6. We're gonna get rid of the base of the 3, so we're gonna have 2x minus 3 on the left side equals to 3x minus 6. Now we're gonna move, like, I did it just, I moved the 3x to the left side, so minus 3x, and for the left side, plus 3. So, that's gonna give us, like, negative x equals to negative 3. I multiply it by, minus, so equals x equals positive 3.
Perfect. Did anybody have anything different than 3? No? Okay. One more. Let me take that singles. Actually, Jelisa, Michael, Lady, Lola, absent. Jonathan, absent. Rena, Denisa, absent. Samantha here. Nicole, here. Andy here. Priya, here. Andrew here. George here. Mariana here. Danielle not here. Fatima Fatimata here, Asmain not here, Shuing here, Chloe not here, Kathleen here, Brennan not here, Rahim not here, Shahana here, Leonardo not here, Brian R, Brian V, absent, Gian absent, Alex here, and Anastasia. Any volunteer for E? Jannah. Mm-hmm. Yes, mm-hmm. Well, X plus 2. Mm-hmm.
And then, subtract. Well, that you can add one, and subtract four. You get negative 3 next to it.
93x equals 3.
5 times. You get actually.
X equals 17. Any question? Okay, now the next type. In the next type, unfortunately, we cannot rewrite the bigger base using the smaller base. They look same, but we cannot rewrite them. And when I say rewrite, it means as a power. We can rewrite 8 as a 4 times 2, but it's not allowed. You can only rewrite using a power. Can you rewrite 8 as a 4 something power? Is 4 something power equals to 8? No. So in this case, since we cannot rewrite any base in terms of the other base, but if you observe carefully, both of them actually have some smaller number in common, 2. So when you have something smaller, both of them have the same number in common, we are going to rewrite both of them using that smaller number. And we are going to do the same thing as the rest once you rewrite the 2 bases. So 8 and 4, both of them need to be rewritten. And what you're going to use? What to the what? 8 is 2 cube and 4 is 2 square. So we rewrite the bases only, but leave everything else same. Four x minus 1. 4x minus 1. So only the bases is different. And we do the same thing what we did before. We're going to distribute the 2 bases, 2 powers. So 2 to the power 3 times 4, 12x. So distribute minus 3 equals, we distribute again. So we get 2 times 4, 8x minus 8. And now it became the same as the first one. Same 2 bases. Fill them and set the powers equal to one another. We need to subtract 8x. And we're going to add 3. So we get 4x equals negative 8, positive 3 is negative 5, right? 8 minus 5 divided by 4. And you get x equals negative 5/4. So everything else is same, just the first step is different. In the final exam, you're going to have one example from type 2 or type 3. So go ahead, try one. Ready? Anastasia, would you like to help me with this one? Perfect. So equals 3 to the what? Mm-hmm. 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 Okay. Connected field. Oh, what do we do? 3x plus 4. 4 from the side. So negative 16 equals 3x. Divided by 3. X equals negative 16/3. Any question? This is correct, right? Good job. Now the fourth type. In this type, we have two different bases on both sides of the equal sign, which cannot be rewritten anyhow. So on the left side, we have 7 base. On the right side, we have 3 base. There's no way we can change them into anything else. Both of them are prime numbers. So if you bump into this situation, then we need the help of something else. So since this is exponential function, we go to its enemy, which is logarithmic function. And we call them, hey, log, please come here, fight with the exponential so that we can solve for the variable. So logarithmic functions comes happily, and we put them on both sides of the equation. It's not a multiplication, it's applying logarithmic function. So there are two types of logarithmic function. One is called log log, and another one is called ln, which is natural log. Natural log. It's a log, but it's a natural log. And just normal log is general log. General log. You can call any one of them. The general log, it has a base 10. And the natural log, it has a base e. So for numbers, you can apply either one of them. It doesn't matter. However, if you have e as your base, then you definitely have to call the natural log. The logarithmic function will not, it will help you, but it will take, you have to do more steps. But if you just take natural log to get rid of the e, anytime e and ln, they're next to one another, they kill one another and they both die. Okay, so in other words, they cancel one another out. They cancel each other out, so we left with 1. So here we have 7 and 3. It's up to you which one you want to use, the log or ln, which is the natural log. I prefer ln because later we're going to have e base. That time you have to use the ln base, natural log, ln. Okay. So what ln does? If it's not e on the base, then it doesn't kill the base. Instead, what it does, it takes the power on the base and bring it down as a coefficient in the front. So the x minus 2 cannot stay on the power anymore because of the log. It just pulls it down. As a result, it comes down as a coefficient, and we get ln of the base alone. So ln of the base without any power, or log of the base without any power. Where did the power go? It came down on the coefficient, as a coefficient in the front. That's why we call the log function. Because if you put log with exponential loses its power. There is no more power left. On the other side, there is no power, so we get simple ln of 3. Now, ln of 3 is a number. Log, they are functions. So it's like if you have log x, this is a function. So if you have log 7, it's a number. So this is a function. When you have a variable, and when you have a number, it's just a number. Okay, it's not a function anymore. So what it does is it brings the power down, and then we use algebra. There is no more exponential function here. It's a simple algebra equation. Since our goal is to get this x alone, that means we need to get here the minus 2 and the ln of 7 from x. Which one do you think we should get rid of first? The minus 2 or the ln of 7?
Fine.
What's the relationship between x minus 2 and the ln of 7? We shouldn't distribute because our goal is to get the x alone. If you distribute, you get 2 x's. You're increasing the x. So this is just like normal 3x minus 2. You can divide both sides by 3, and then you add 2. So same scenario is here. You divide both sides by multiplication. So there will be no more multiplication. You have x minus 2 equals ln of 3 divided by ln of 7. And now life is easy. All you have to do is add 2 to both sides. So whatever we have, that's our x. So if it's in the non-calculator portion, you stop here. But most likely it will be in the calculator portion. So if it's in the calculator portion, you have to go to your calculator. And depending on what type of calculator you have, you are going to find this number differently. For calculator in the computer, they cannot accept the function first. First, you have to type the number and then the function. But many scientific calculator, you can press the function first, like log first, and then insert the number. Like for example, here, if I try to put log, it is invalid. So you cannot put the log first. First, you have to punch the number. So 3 ln divided by 7 ln. And my computer automatically close the parentheses. But if you're using scientific calculator, it will not going to close the parentheses. You have to close the parentheses manually. So whatever I'm typing, look at the top bar. Everything is shown here what I have. I have ln of 3 within the parentheses divided by ln of 7 within the parentheses. So we have to have exactly written that way. So we have the fraction, and now we are adding 2 plus 2. So the answer is 2.56. 2.56. Usually in the final exam, they mention how many digits you have to go. Or it's in the multiple choice part. Now I use ln, I got 2.56. If you decide to use log, let's see, do you get the same answer or not? So log 3 log divided by 7 log. And then we are adding the 2. Ta-da, same answer. So for number, it doesn't matter which log you use. You can use ln or you can use the general log. However, they are not same. For example, 2 log is 0.301. But look how much is 2 ln, 0.69. So they are not same, but when you try to solve, they work same way.
If they're not the same, if they ask for the answer like that, and you respond for this, that's still the right answer.
Why they give you the same result is because you're applying log to both sides. When you apply log to both sides, you end up getting log division. So they're not same, but the division are same. The quotient they get from the division, that's the same number. So if you don't divide, like if you have a situation where division is not necessary, then you're going to get 2 different results. So you have to have the division. The division is same for them, but individually they are different. For example, 10 divided by 5 is 2. 3 and 6, they're totally different than 5 and 10, right? But if you divide 6 divided by 3, you get same answer too. So there are 2 different numbers, but the divisions gives the same results. It's something cool about log. Okay, go ahead, you try one. Ready? Rena. Help me with this one, please. Rena.
I might have mistake. But like, anyway, so.
Oh, you're doing it, like no problem.
So we need to do the LN. So to do that, we're gonna put first, yeah. And the first bracket of 2x minus 2.
2x minus 2 become coefficient.
ln of 3
Mm-hmm.
equals to ln of 2. To get rid of the ln of 3, we're gonna divide both of them by ln of 3. Yeah, we're gonna put that off, and we're gonna have on the left side 2x minus 2 equals ln of 2 divided by ln of 3. I got rid of the 2, so that's plus 2, so it's gonna be 2x equals exactly ln of 2 divided by ln of 3 plus 2. And I divided it by 2 to get x.
And you have the same thing. You can keep the same thing, or you can rewrite division as a multiplication of the reciprocal.
I also want to like that.
So it's ln of 2 divided by ln of 3 plus 2. And basically you're multiplying by 1/2. Dividing by 2 means multiplying by 1/2. So when you multiply, you distribute into both of them. So we get x equals ln of 2 divided by 2 times ln of 3. And here we have 2 divided by 2. So if we have, let's say, 1/5 divided by 2, this is same as 1/5 times 1/2, right? Because we don't know how to divide. Instead, we do multiply of the reciprocal.
Just like nothing you have, just like we learned during like the outer layer with the inner layer. If you know what I mean, like you put, so can I write it? Just like, wait, if you have, it was like a trick, like which they taught us like that. So in this case, wait, let's say you can do ln of 2, ln of 3, and divided by 2, right? So you would put 1 here like that, and you would do this together with this times. So you would get ln of 2 and 2 times ln of 3.
Okay, I see.
That's like
So
the outer,
multiply-
exactly.
Multiply these two.
The outer layer
And
with
then
the
divide
inner,
by
with the
2.
inner layer.
Oh, cool. Wow. Anesthesia.
Question. Get rid of divided by 2.
Yeah. So this is our last step. X equals ln of 2 divided by 2 times ln of 3. And we don't need a parenthesis. Yeah. Plus 1. Now you may wonder, can you cancel the ln of 2 with the 2? Like this 2 with that 2. Can you cancel? No. Why not? Because this is not real. It has a home. It's an exponent. It's, how do you call it exponent? It has a home. And that 2 on the denominator is a homeless. So they cannot be combined. So you go to the calculator. And you find out how much is this. And you have to be very careful. All of you try finding this one in your calculator, in your phone. If you have an iPhone, just tilt your phone horizontally, it will become a scientific calculator. Does anybody have the answer yet? 1.4838.
3.8.
Anybody else?
So it's like, I think that's.
You get 4 if you do that. Like,
That's because you have to know how to insert it.
Okay.
Who has something different? A different number? Alex,
no.
1.32. Anybody else has anything different?
1.31.
1.31. George? 1.38. Okay, anybody else? So we had so different answers, but they're close to one another, which is a good thing. In my other class, we had totally different answers. And that's because you need to be very careful about your parentheses. So when you insert, depending on your calculator, you have to put parentheses first, ln parentheses 2, close your parentheses, divide, and then another parentheses, because you have 2,000 the denominator. 2 times ln parentheses 3 parentheses. I need to close these parentheses. So this parentheses is closing here. Now we need to close this parentheses. So we need a bigger one. And then plus 1. So scientific calculator is very parentheses sensitive. Now let's see, what do I get? 2 ln divided by another parenthesis 2 times 3 ln, close the parentheses twice, plus 1. 1.315, 1.315, which is 1.32. Now, why do you have different answers? It's probably because if you did not put everything together on your calculator, if you did this part first, or if you did this part first and then you added 1, like if you did part by part, then it has some rounding error. So if you want to get exact solution, you should put everything together. Otherwise, there will be some rounding error. Any question? No? Now the last type. The last type of exponential function, which is reserved for 12.8, but we are going to put it here because it goes all the way the other 4 type. In this type, we have one side, on one side of the equal sign, we have only one exponential term plus a number, either addition or subtraction, a number extra, non-exponential term, equals to another number. So one exponential term, but multiple numbers. So if you have this scenario, then your goal is to combine all the numbers on one side and leave your exponential equation on one side. Once you have your exponential equation alone on one side, then you can call its enemy the log and then apply the log function to bring the power down. But here we have a special base, E. For E, we shouldn't call log, we should call ln. Why? Because when ln and E together, what do? They cancel each other. So in here, we have the exponential function minus 3 plus 16. So that means we need to get rid of the 3 from both sides. I mean, at least from that side. So that we can get our E to the 2x alone. And on the other side, we have 19. Since exponential is alone, plus our base is special E, so we need to call the ln. So you go ahead and call ln. Now while ln counts, it fights E so hard that they both die. As a result, there is no exponential term anymore. We have a simple algebraic term 2x on one side, and the other side is a number ln of 19. What is our last step? Divide by 2. So x equals ln of 19 divided by 2. You leave it if it's not in the calculator portion, but most likely it will be in the calculator portion. So you do, it's decimal. And this one is easy. Punch ln of 19, close the parentheses, divided by 2. Just like if you have x square and check the square root, they cancel one another. Same thing, E and ln, they are opposite of one another. Actually, it's opposite, they are inverse of one another. So they cancel each other. Where's the number? 1.32, 1.4, so let's check, simple one, 19 ln divided by 2, 1.47. Now, if you decide to use log here, look what happens. 19 log divided by 2. Completely different answer. That's because it did not divide this ln by anything. If you divide ln by ln, or if you divide log by log, then they are same. Otherwise, they are different. Okay, go ahead, try one. So one of these, type 4 and 5, one of these will be in the final exam, and one of type 2 or 3 will be in the final exam. And all 4 will be in the in-class exam.
So exam to find
Final is in December. Next exam will be when you come back from Thanksgiving, I think. You guys should start getting your scientific calculator so that you can play with them. In the exam, you're not allowed to use the phone. You must use scientific calculator. So if you have no idea how to use it, if you borrow it during the exam day, you'll be in trouble. So you should have one that you know how to use. Especially the exponential, log. These are the most important thing in the scientific calculator for this class. Ready? Rhyme. -4, -4. The 3 e to the x equals 1.6. Good. Divide by 3. We cannot use log until exponential is alone. So we need to get rid of that. 1.6 divided by 3. We put ln on the sides and ln and cancel. X equals ln of 1.6 divided by 3. And did you find out how much is this? What is this? 0.628, which is 0.63. And let's see. Close 1.6 divided by 3. Take the ln negative. So yeah, sometimes you get positive, sometimes you get negative. It's negative probably because it's less than 1. So do you remember the exponential function, the shape? The exponential function goes through y value 1. Since its inverse is a logarithmic function, they actually do the other way around. They go through the x value 1. So this is log of x or ln of x. And this is any type of base to the power x. So this number 1.6 divided by 3 is less than 1, somewhere here. So y value is negative. Any question on any of these exponential equations? No? So you may wonder, why do we care about all these exponential equations? We do care because we need to use the knowledge to work with money. And we love money, right? So we need to use that on something we love. Let's say you're investing some money. So you need to calculate how much money you're going to get in the future. Or how much money, if you want a certain amount of money after a certain amount of year, then what interest rate should you ask to the bank to pay you? So you need lots of information. So when you invest money, there are 2 types of formula you need to deal with, and both of them are exponential equation. The first formula says, if you compound your money n times in a year, it means if you ask your bank to use your money n many times in a year, then to calculate your final amount, they're going to use the first equation. The first equation says A means the final amount equals P means the principal, how much you're investing today, times 1 plus R. R is the interest rate they're going to pay you, divided by N means how many times they're allowed to use your money. Whole thing raised to the power N times T. T means how long you're going to keep your money in the bank, the time. Now, if you ask them to, they're allowed to use a certain amount of time, that means you have an N, which is the number of times they're allowed to use your money. It's called compounding your money. There is another time. They don't need to compound a certain amount of time. They can compound continuously. Like they can use your money in every moment. So if you don't have a certain number that you can use for N, then you have to use a formula that doesn't have any N. So we use the second formula, A equals P times e to the RT. Here there is no M. We have only R, which is the interest rate, T is the time, and the base E is the same number as what we had in the last page, the number E. And P is the principal, A is the final amount. And yes, you have to memorize these formulas. So make sure you write them down and have them memorized. The top formula says A equals P times 1 plus R over M, whole thing to the power N T, M times T. We usually use the second formula a lot because that gives us the most benefit. So people remember this formula saying part. It's a part formula. Like it does look like it's part, even though it's P times e to the RT, but they easily remember it using a short expression part. Now let's see, where do you use it or how do you use it? Let's say for some reason you need $14,000 in 8 years. So you went to the bank and told them, you asked them, how much money I need to invest today so that after 8 years, I can have $14,000. Bank said, well, I'm going to give you $7,000. Sorry, 7% interest rate. So how do you want to invest it? For some reason, you decided to invest it quarterly. Quarter, can you see a quarter? Can you name a quarter? Quarter means what? 4. 4. In a dollar, we have 4 quarters. So quarter means 4. So when you can see something, it's M. If you cannot name something, you cannot see something, it's continuous. So quarterly means you have it, you can see it. They can invest it 4 times in a year, and they're going to give you 7,000. I'm just saying 7,000. 7% interest rate. So which formula they need to use to tell you how much you can invest today? The first formula or the second formula? They have to use a formula. Which formula makes sense? The first, because we have an N. Anytime you have an N, it's the first formula. If you don't have an N, it's the second formula. So the banker, let's say for some reason the computer crashed, so he cannot use the computer to find out everything. So he has to do everything by hand. So he wrote down the formula. A equals P 1 plus R divided by N, whole thing to the power NT. Do you know how much is, oh, we are looking for, let's level them. What is this $14,000? Which variable? Future amount. So you need 14,000 in 8 years. So after 8 years, you need 14,000. So it's 14,000 is the future, which is A. Now, how long? What 8 years means? What is given here? T. Interest rate is 7%. So what is this 7%? R. So R is 7%. Unfortunately, you cannot use percent. You have to convert your percent into decimal. So you rewrite your percent into decimal by removing your decimal into 2 places to the left. So it's 0.07. And then we are doing compounding quarterly, means N equals 4. So we have everything else given. What is not given? P. So we need to solve for P. So let's divide both sides by whatever we have next to the P. That cancel out. And we have a straightforward equation for P. P equals A divided by 1 plus R over N whole thing to the power NT. And then he just substitute everything given here. Our A is 14,000. 1 plus interest rate is 0.07. You're compounding 4 times a year. Whole thing to the power 4 times 8 years. Now 4 times 8 is what? And then you have to solve for P anyway. You have to do it anyway at the end, right? So if you do it at the first, then it will be easier to calculate at the end. Because our P is single, so you can easily calculate it. Okay, go ahead, use a calculator and find out how much you have to spend today. And you have to be accurate. Otherwise, he can sue you, the customer. Alex, what number you have? 8036.17. Okay. Now who has something different?
$8,052.57.
52.57. Anything else? Brian, what do you have?
I got 80.03, but I forgot one of the zeros.
Jahana, what do you have?
I got 8,035.75.
See, so many numbers. Andrew, what do you have?
8,036.73 cents.
73. 8036.73. George, what do you have? 803575. Okay. Anyone else? 3575. Anyone else? Fatimata, what do you have? Same as the last one. Looks like many people have the last one. So let's see. We have 14,000. We are dividing by, since we have so many things on the denominator, so I need to put a big parenthesis. No, we need double parentheses because we have to use the power. So double parentheses, oops. Oh, I cannot go back. 14,000 divided by double parentheses 1 plus 0.07 divided by 4, closing the first parentheses, and the power. So every calculator has a different power. For the computer calculator, power is represented by x to the power 1. You click that, we'll get the power outcome. So power means x to the y, and you get a little squiggly thingy. The squiggly thingy is the power. 32. You close the parentheses for the denominator and enter hit. 803575. So the winner is this. So see, there are so many choices depending on how you punch. Did you guys punch the same way? Like, why do you have different numbers? Did you do part by part, or did you put everything together? If you did part by part, then you're going to have rounding error. All ones. For all ones, the last one is the correct one. But if you do part by part, like if you do a division part, and then this, and then that, and then divide, then you're going to have a rounding error.
Also,
Part by part?
I put it on like different kinds of it.
Wow. So you have to get used to the original real calculator. So when you do homework, guys, please try to use that calculator, but sorry, not your phone, but the actual calculator, which you're going to use during your exam. Okay, so now we are going to do a series of same question. Let's say you have $7,000 from working part-time, okay? You save it. And now someone gave you the idea, hey, don't save it, invest it. You're going to gain money. So you went to the bank and told the bank that, hey, I have $7,000. I would like to compound it annually. Bank said, okay, we are going to give you 3.5% interest rate. You cannot argue with the bank about your interest rate because it's their choice. So he said, okay, but tell me how much I'm going to get after 8 years if I invest that $7,000 today. So investing $7,000 today, and you want to see if you save it for 8 years in the bank and don't pick up that money from your saving account, then after 8 years, that $7,000 will turn into how much? Okay, so, oops. Come on, it's not this way. Now, this $7,000, what is the $7,000? P. A is the future amount, what you're going to get after $8,000. Sorry, after 8 years. So you're investing today, which is your current money, your present money, your principal. 3.5% means what is your R? You move the decimal 2 places left, 0.035. Investing annually. What is this information? Really? If you do something annually, how many times you do it in a year? Once. And you have to wait 8 years. Means what? T equals 8. So formula which you have to memorize is A equals P 1 plus R over M whole thing to the power NT. You go to the formula and you apply all these variables. $7,000 principal, interest rate is 0.035. You're doing it only once a year. You're multiplying 1 times 8. This one is easier to handle before you plug it into the calculator. We have 1 plus 0.035 to the power 8, which is a simple number, 7,000 times 1.035 to the power 8. So go ahead, figure out how much is this. Andrew, what number do you have?
217.66 cents.
Same. Does anybody have anything different? George, what do you have? Same? Okay. So you said, well, 7,000 turned into 9,217. Let's see how it changes if I decide to compound monthly instead of annually. So if you do it monthly, it means how many times you're doing it? 12 times. The same formula, the only thing different is the n, not 1 anymore, it's 12. So A equals P 1 plus R over n to the power nt, 7,000, 1 plus 0.035. You're dividing by 12 and 12 times 8. So go ahead. And if you want, you can instead of 12 times 8, you can simply write their product. Do you know what is 12 times 8? 96. So if you know it's 96, just punch 96. If you don't know, then for power, you have to put a parenthesis. And you know, some scientific calculator, you don't have to keep punching new keys. You can just click on the old keys and then you get the same thing again. You just have to change, you can just change the numbers, whatever you want to change. So I highly recommend you to play with your calculator, which you are going to use during the exam. It will make your life much easier. Shahana, what do you have? Oh, not yet? Okay. Andrew, done? Not yet? Okay. John, done? 9 and what? 258.13. 13. Alex, same. Kathleen, same. Same. Great. So what do you observe from left to the right? You got a little bit, you got a little bit more money. So here it's got 17, here you got 58. So you get greedy, like, oh, if I compound 12 times, I got more money. What if I compound daily? Then how much I'm going to get? So daily means how many times you're going to do it? 365 times. So A equals P, 1 plus R over N, whole thing to the power NT. So principal is 7,000. Oops, what I'm doing. Times 1 plus 0.035 divided by 365 to the power 365 times 8. How much money are you going to get? What do you assume? Less than 58 or more than 58? More? Alex, done? How much you have? Wow, 58 to 61. 58, 59, 60, 61. $3. And here 17 to 58. Wow, lots. Same number, different number, same. 61. Jahana, you got something different? No. You know, by nature, humans are greedy, right? So you get more greedy. Like, oh, wow, I got more money when I do 365. So what if I compound continuously? You're compounding it every second, every moment. So 365 was the highest number in a year, but now you want to do it in every single moment, every single second. So we cannot have a number for that, right? If you're doing something continuously, which formula is supposed to use? The part formula. There is no n here. We cannot assign a number to m. So this time our formula suddenly changed to a equals p times e to the power rt. So 7,000 principal, e to the intercepted 0.035, and you're multiplying with 8 years. Now find out how much is this. $261 point what? 90? So basically 62. 91. Well, your greed didn't get you not much money. It just got some money, some cents more. So the same 61, but the cents a little bit more. Not bad, at least 1 penny more, right? So what did you learn today from all these calculations? If you want to get the highest rate, which option is better? Continuous option. So if you ever, like in your real life, if you ever invest something, don't let the bank to fool you, okay? Now today you learn very helpful information, very useful information. Use it in your real life. When you really invest your money and you go to bank to talk about your options you have. They cannot fool you anymore. Okay, so now you have $3,200 currently, and you want to get $4,600 from your $3,400, $3,200. So you have $3,200 today, but your goal is to make this $3,200 to $4,600 somehow. So you went to the bank and told the bank, hey, bank, I want to compound continuously because now I know with compound continuously, I'm going to get the highest money. So you're doing compound continuously. Bank said, okay, I'm going to give you 4.3% interest rate. And now you're wondering, well, with 4.3% interest compound continuously, how long do I have to wait to make my 3,200 into 4,600? So which formula? The first one or the second one? Third. Anytime you see continuous, it cannot have an n. So you have to the formula that doesn't have any n. So a equals p times e to the rt. Now, do we have our final amount? The future amount. How much is the future amount? 4,600. That's your goal to get. How much you have currently to invest? 3,200. E to the, what is the interest rate? 0.043. So 4.3%, you have to move the decimal 2 places. So 1 place is empty, you put this 0 for that. And then t you don't know, so you need to solve for t. And now this is an exponential equation because our variable is on the power. Anytime a variable is on the power, it's exponential. So to solve exponential, you need your logarithmic equation, the enemy. So what is our first step? Our goal is to get this t alone. So what do you get rid of first from t? Divided by coefficient. So they cancel out. And here it's easy to cancel both of the zeros because they're both on the top and on the bottom. And 46 and 32, they both are divisible by 2. So you can divide them by 2. What is half of 46? 23. And half of 32? 16. E to the 0.043 t. Now, which one we can get rid of first? E. So what do we call? The ln. We call ln, hey ln, can you please come? Ln said gladly. So it comes to both sides. And then what happens? They cancel one another. So we get ln of 23 divided by 16 equals 0.043 t. 0.043 t equals ln of 23 over 16. And then we need to divide by 0.043. The t is ln of 23 over 16, whole thing divided by 0.043. So how long time you have to wait? How many years? Is it straight 8 or it's a decimal? 8.4. So it cannot only 8 years, right? You have to 8 years and more. So technically you console yourself saying, well, I have to wait 9 years because 8 years is not enough. You have to wait 8 years plus more. And if you have no idea how long more, just assume it's 9 years. But it's definitely not 8 years. It's more than 8 years. So realistically, you have to write 9. But depending on your multiple choice, you write whatever choice they have. So is it worth it? You have to wait 9 years to get 4,600 from your 3,200. I rounded up because it's a realistic situation.
Oh, okay.
You cannot say you have to wait only 8 years because it's not possible, right? 8 years plus more. How long more? If you have no idea, tell yourself it's 9.
On the cash to be now.
It depends on the multiple choice.
Oh.
Most likely there are multiple choice. Okay. So investing with low amount, low interest rate is not worth it. One last question before you go. And then you'll be done at 12.3. So you can start doing your homework for 12.3. So you've done it 12.1, 2, 3. So you have 3 homework and quizzes too. The last one is missing interest rate. It says an initial investment of $2,250 is made compounded continuously. After 6 years, this 2250 turn into 3100. So what's the interest rate they applied? The $2,250 turns into $3,100 if you decide to compound continuously and wait for 6 years. So what is 2250? Is it A or is it P? P, the principle you have today. Compound continuously means which function? Which formula? A equals P e to the RT. After 6 years, what is this 6? T. After 6 years, the amount is 3,100. What is this 3,100? A. So we don't know what is interest rate. So 3,100, principal is 2250. E to the, we have no idea the interest rate, but we do know we have to wait, not 8, we have to wait for 6 years. So this situation is same as the last one. We are missing something that is on the power. That means it's an exponential function. Anytime variable is on the power, it's exponential. I should write this down. Variable is on the power means exponential function. Why do we care? Because to solve exponential, what do you need? ln. So which one you get rid of first? 2250. 2250. And this time we can cancel by 0. And both of them are divisible by 5, but I'm too lazy to use my brain. How much? 62 over 45 equals e to the 6r. And then what do we do? We go call the ln. What ln does? Cancel the e. Oh, wow, I wrote 2, it turned into a heart. Wow. Even computer loves this question. 62 over 45, they cancel out, equals 6r. So last step is divide by 6. Let me know how you have a number. How much? 5.3. And what's the next number? 4. What tomato? You have a different number? So this is your R, okay. 0.054. And for when you mention interest rate, we mention as a percent. So you move the decimal 2 places and you get 5. What was the number you said, guys? 34. So 5.34%. Both of them are correct, but we don't say 0.00 as when you speak. Point is big, we mentioned percent. No, bank doesn't do that. They don't do that because if it's 5.6, they have to give you 6%, which is a huge amount. So,
They are gonna have to in class, right, for sure.
quiz?
Yeah.
I should give you one from, what do you prefer? No, it should be a good practice, guys. A good practice for you. One question from exponential, the 5 types of exponential equation, and one question from the money problem.
So mean.
No, it's a good practice. Do your homework, and then I'll see how much homework you have done. So 2 questions. 2 questions, okay? One from the 5 types of exponential function, exponential equation, and one from the application of the exponential equations. And don't forget to do homework, 12.123, homework and quizzes. So have a good weekend, everyone. Even quiz is a good practice, okay? So don't blame yourself.
Today, like, last week we said it's gonna be
Exactly.
today, so like, we're not that way.
Huh?
What exactly am I waiting for?
What or how long? What do you
What am I waiting for? That's something else.
the code?
So why did they just send the code like a Gmail or something?
They don't deliver via online. They deliver via postal mail, the post office. So you'll receive a card with a number. So you have to scratch off the aluminum thingy to get the code, and then once you have it, you go to MyMathLab, they'll ask for the code, and then you insert the code.
Sure, what am I waiting?
Call them, call Pearson and ask them why is it, like how come it's taking too long? Because I remember you told me last week, right, that you delivered, I mean, you ordered.
Or guess yourself.
Please stay. Okay. So 7 to 5 business days, 5 to 7 business days. 5 to 7 or 7 to 10, it depends.
Okay, and you left that after everything?
Let me know when you have the code. The last day for everything will be closed, MyMathLab. Last day of class is December, right? So December 15. I'm going to, bye guys. I'm going to close everything by 9.
Right.
Mm-hmm.
Okay.
December 9.
I burned myself up by doing everything at one time.
So December 9 will be the last day.
So I think I'm just gonna do like, maybe like 4 a day. Now we guys have time to study for other classes.
Do you think you're going to finish the entire, how many sections, 30 sections or something in 4 days? Homework plus quizzes.